Hello everyone, myself Devor Naik. So today we can discuss about electric field due to a charged ring. So electric field due to a charged ring at its axial point. How to find out? A charged ring is there. Let's say Q charge is there, and we have to find out electric field at the axial point P. So like the previous video, you can check out that previous video, electric field due to a charged wire, right? Straight wire. Likewise, we will take a small length element dl, and so small charge will be there, that is dq, total charge, let's say q, and we have to find out electric field at this p point. So let's say this is the radius of the loop capital R, this is small x. So distance from length element to p point where we have to find out electric field, that is r square plus x square root over. So electric field for this let's say dE is equal to electric field at P point will be in this way, dE, and for this small length element electric field will be on this way. So along x direction, component of this electric field will come out. See, this is a positive charge, electric field will be away from the plus charge, okay, at this point away. So a component will be there for this dE. So this is dE cos theta, and this is dE sin theta. Likewise, dE cos theta, dE sin theta. So dE sin theta components are cancelling each other. So net electric field along y direction is equal to 0. As all the electric field components are cancelling each other, we take two length elements. If you will take 4 length elements here, so upside 2 dE sin theta, downside 2 dE sin theta. So all x, y components are cancelling each other. So net electric field is only for x component. Okay, so E net is only for x component. So that is dE cos theta. Okay, so now we can integrate this both sides. If we will integrate 0 to 2 pi r, so dE, value of dE we will put it. So net electric field is integration of dE. So electric field for this small length element at this point, k lambda dl k q by r square. R square means this distance. So distance is r square, sorry, capital R square plus x square, okay, square root over the only this much. Cos theta is x by, again, r square plus x square root over, so this is 3 by 2. Here power 1, here power 1 by 2. Okay, so directly power 3 by 2. So net electric field will be k lambda by r square plus x square power 3 by 2 okay, integration of dl 2 pi. Okay, so dl 0 to 2 pi. This length element, minimum value 0, maximum value 2 pi. So limit is 0 to 2 pi capital R. Okay, 2 pi capital R, and x is there. So this is, this much. So this is charge distributed charge. Okay, linear charge distribution. This is the length. So lambda into L, that means Q, total charge, capital Q. So K Q X divided by this much, R square plus X square root over the power 3 by 2. Same thing, 3 by 2, same thing. Okay. I made a new format, but same thing. Okay, K capital Q, this is total charge, this is X. Okay, what is X? From the center of the circle charged loop to point where we want to find out electric field. So this is very important. So you can remember this. This is important. This format is very important. You remember the format. K constant, Q total charge. Okay, total charged object, whether it is a loop, whether it is a cell, spherical cell, whether it is a semi-sphere. Okay, so and this x is distance. Okay, from the center, see, from the center of the charged loop to P point. That means this x is this distance, but r square plus x square of power 1 by 2. This is also a length. Right? And what is that? You see, from each charged length element, from each point, from the loop to this P point, all distance are same. This distance is same. From this point to this point, this distance is same. Can you understand this? A charged loop is there, and here I want to find out electric field. So from each charged point to this P point, all distances are same. Here this distance is same, this distance is same, because it is a loop. Okay, so from each point to from each charged point to this P point, all distances are same. So this is a important term. Okay, from each point to P point, all distances are same, right? So remember that term also. Okay. So this is an important derivation. You can find out electric field due to charged loop. Another, why I am saying that, just I will ask you a question. You can understand what do you mean by that important term. Suppose a square is there and charge Q are placed at each corner. At the center of the square, okay, P point is there. Find out net electric field at this point. So how to find out? This is very simple. Electric field for this charge in this direction, electric field for this charge in this direction, electric field in this direction, electric field for this charge in this direction. Charge are same, distances are same, so all electric fields are same. Equal and opposite cancel each other. Net electric field is 0. Wow. This is very easy. Okay. So again, that same square. Okay. That same square, but that square is there. This is the square. And find out electric field not at the center. Above point, from the square to a little bit high, h height above that point, P point is h. This is a square, let's say. So electric field at this point is 0. Okay, but I want to find out electric field from the center to h height above. Okay, I want to find out electric field for this square, but at this point. Okay, so there is a height, h height from the center. This is the square and h height. Okay, you can draw like this. This is the square and h height from the center. H height, okay, from the center of the square. So find out electric field at this point. Can you do that? Not 0. This is not going to be 0. Just imagine the 4 charges are there. Here I want to find out electric field. For this charge here electric field. For this charge here in this direction. So no cancelling term will be there. Okay. So just remember that term. Here I wrote that net electric field will be just the format. Okay, that will help you. Just the format. So what was the format? K, that is constant K, Q, K, Q, X, previous one, K, Q, X, and that capital Q was actual total charge on the circular loop. So here total charge is Q, 4Q. Here total charge is 4Q. Same format, K, total charge, again K, Q, X. What was X? From the center, okay, from the center of the loop to P point, that distance. Here this distance is given H, okay, by R square. At that point, from each charge to P point, what was the distance? That distance will be here. Distance to the power Q, okay, that distance to the power Q. This is R. Okay, so how to find out this distance? This is H. This is you can take let's say side of the square is A. Okay, so this diagonal is going to be root 2A. This diagonal of the square. So this distance is half of the diagonal. So root 2A by 2. So A by root 2. Okay, so this distance is going to be A by root 2. A by root 2. So again, this is like, this is A by root 2, this is H. So we have to find out this R, this is R. So R is equal to H square plus A by root 2 square root over. Okay, so this R is going to be A square, okay, A by root 2 square plus H square or root over the power Q. So this is going to be 3 by 2. So this is the formula. This is the answer. Likewise, you try this one. Okay. This is homework. Okay. A equilateral triangle is there. Side A. And find out electric field H height above the centroid. Okay. From H height. How to do that drawing? This is like this. This is H height from the centroid. Okay, this is Q, sides A, and from the center H height. What is the electric field? You find out. This is H for you. Okay, K, total charge into from the center to P point divided by distance from each charge, means this is the distance. This is R. So use your tricks. Okay, to the that the R is this distance to the power Q. Okay, this Q, R to the power Q. Okay, thank you very much.